Okay.
Hey Joe,
Hey Joe.
can you hear us?
Hey guys.
So, what made you decide to apply for this role?
Sorry I'm late, sir.
Yeah, it's all right. It's all right. It
Yeah.
happens. I get you're nervous. So, why did you apply for this role?
Mm.
I thought the company would be interesting to work for, and competitive salary, good benefits.
Ooh, so the money. Okay.
Mostly about the money.
Yeah. So, I guess let's get started. Thank you for being here. So, to our
Yeah.
audience, this is the start of a series that me and FX were going to be doing on like talking to core devs. Basically, we want
Yeah.
to be like a translator. We want to be able to like translate the knowledge that is hidden in the code bases and not really out there to like everyday devs. So that's why we're having this call with no our first guest.
Mhm.
The honor goes
Mm.
to Joe C. By the way, are you
Joseph.
related to John C?
Sorry, say
Are
again?
you related to John C?
No.
Like is
We got
like was that a coincidence? Like your Joe C is John C?
Yeah. Our
that.
last names start with C, but they're different names. Yeah.
Oh,
Yeah. That's cool. That's cool.
that's nice. So
I don't know who was
Yeah.
first to start using just the first initial, but
Yeah.
causes a lot of confusion in places like GitHub and chats because they're very similar first names too. We're only off by one
Yeah.
letter.
yeah, true.
Real.
Oh,
Yeah.
it's funny that
Oh,
everybody has
straight
a
up.
bottle like water around them. FX has one, you have one. That's pretty nice.
Yeah. Yeah.
Yeah. So
Um.
okay, FX, you go on.
You want
I've
to
been
go?
talking. Yeah.
Oh, okay. Yeah. So, yeah, Joe. Nice to meet you. I'm not really acquainted with you beyond just asking questions in your DM about like random stuff on the SVM. Um, but like I think to start, I think can you tell us like your journey, like in terms of what were you doing before you joined labs, transitioning to Anza, and like just basically just tell us like the role you've played. Obviously very known for splitting like the SBM, like leading the splits for SBM and the SBM API, but like just want to hear for the horse's mouth, like what's it been like? Uh,
Yeah, totally. So, also great to meet you guys too. Really appreciate you guys doing this. I think it's cool, and yeah, happy to talk shop for a little bit. So,
yeah.
my, I guess like my journey to Labs Anza was kind of similar to a lot of people I met in the community. I was like working for a bank for a while and started like going to like sort of like doing these like fringe meetups in crypto, like going to these like different events and stuff while I was still working my job and kind of getting interested in what people were doing. And I just noticed that like everybody was building really cool stuff. Like there was all this like technical conversations happening between people, and then, like it didn't. There was no semblance of like I work for this organization. It was mostly people just like doing things themselves. So I thought that was like super cool, and I was kind of hooked from the beginning. And I went to the New York Hacker House and really loved it. And then I started making YouTube content for how to build like Solana programs because at the time, this was I think 2021, there was really no good docs on or no good like video resources. The docs weren't great either. And even Rust didn't have like a ton of great tutorials because some
Yeah.
good ones, but it
Yeah.
was like
Yeah.
still like the YouTube space was still catching up. And there's a lot of YouTube space. There really wasn't much. So I just started like filling that void. And that's how I ended up at Foundation. And then from there, moved over to Labs to work on some like program stuff and some SVM stuff. And have been doing that for the last 2 years.
Whoa, pretty
Yeah.
impressive.
Cool. Cool. So
So when was
yeah,
when was the last? Sorry, when was the last time you recorded a video for YouTube?
Um, Honestly, it's probably been a couple of years now. I think the last time I did was at Foundation. I was doing the Solana Bytes videos that are still on the channel,
Oh,
on the
you're
Solana
the one who
channel.
recorded them.
Yeah.
Wow, like
yeah.
they really helped me out. Like they really helped me out. Like I'm pretty green to Solana. I've been here for like just a year, so your videos really helped me out. Thank you for those.
Awesome. I'm
Yeah.
glad. Yeah. Those I hopefully think are still useful. I mean, I think the Bytes ones were a little bit better for like the original ones I made, like the old ones. I have no idea if I had followed any best practices or anything. I probably did like so many things wrong.
Yeah, but I think that's one of the best ways to learn development, especially in like the chain, because one thing I got into Solana straight from school, so I didn't really have a lot of outside work experience. So I started thinking it was like from like a senior year, like sophomore. So like it wasn't really a, oh, I worked on this, found this kind of Solana kind of found me in school. So one thing I had to learn was reading code, because because I came from, like, I learned TypeScript and I was going into Rust, so like I was very familiar with like the React code base, the Node.js, the Next.js code base. Those are very mature code bases, and like they're very documented. But coming into Solana, a lot of things were just a lot of things were rough, so so I
Still
had
are.
to, yeah, so I had to pick up really fast, and one thing that kind of like has shaped my journey here is just being comfortable with like expecting the worst. Like once I get into a code base, it's almost like if I see that it's properly written, properly documented, I'm kind of like, because I didn't expect that, like
Like
it's kind
good
of
dogs
like,
is
yeah,
surprising.
it's so common that it has become, like, it has been turned into a meme. On Solana is like chewing glass. You just it's just like chewing glass. You kind of like just expect that you're gonna chew glass whenever you go hop into a code base. But yeah, pretty cool introduction. Pretty humble though, because we know you. You
Exactly. We
know,
know you. We know you.
pretty
We
humble
know you.
because we know you. Yeah. So, fairly, do you want to like dive into the questions? Let's get straight down into the business. Yeah.
Yeah,
Let's do it.
let's
Let's
do
go.
it. So, from our conversations, you said you mostly work on the runtime, VM, and like program side. So, we wanted to like know what's the, let's say, the life cycle from a transactions view, from the message to execution. Sorry, from the point where the RPC does like send transaction to the program entry point. So, like, what's the life cycle? Can you like sum it up for us?
Okay, sure. So to start, every node runs what's called a bank, and that's like part of the banking stage. But the bank itself is like a big, it's kind of like this big like operating unit that controls, like, it handles all the different things that are going to eventually land into a block.
Yeah.
It's actually like more than just a block. It does like snapshots and stuff like that, and it manages it interacts with the accounts database. It's like we basically put everything in this one component that can be like spun out on multiple threads. Like you can have multiple banks, and like each one gets a slot. And so when you send a transaction to an RPC, the RPC right now
Yeah.
communicates directly to that bank component. We're trying to decouple that relationship so that you could run an RPC without like running a full validator. But right now, the two are
Yeah.
pretty tight coupled. And
Yeah.
so when you send a transaction, it will obviously get all of the account state and its like current understanding of what has already been processed for transactions from that local bank that it's sort of coupled to. And then you go through the process of sanitizing that transaction message, making sure that everything like follows the rules, and being able to compile it and get the biggest thing is like the SIG verification that happens earlier, but also being able to look at the transactions like account indexes. So you need to know like who's writable, who's a signer, and who's read only. And this process is pretty strict because like that, aside from the signer bit, that's like what enables all the parallelism in the runtime is like those
Yeah.
indices. So that stage, happens pretty early on and make sure that the message is valid. And
Sorry
then
to cut you off. Okay, the point of the of sanitizing the message is to verify who's right, who's read, all that before you actually start the process.
yeah, there's some other rules that are like a little more nuanced. Like there's a set of keys that can't be right locked or, things like that. But for the most part, yes, it's designed to basically say like is everything aligned and can we convert it from having whatever kind of instructions are in there and whatever kind of explicit account declarations and keys to this like minified index-based representation. So like if you look at a message, you'll see like indices of like writable, indices of read-only. It's kind of like listed in the message header. And that is like a small, like very easy way for the rest of like the runtime to key on what that transaction is going to do to account state. So obviously, like if you think about a thread pool, like the whole way this thing is architected is if you can like look at a transaction, you know it's been like sanitized and it's going to mark some list of accounts as read only and maybe a few as writable. You can use that information to build out like a thread pool architecture of like what transactions can be run
Yeah.
on which threads. And obviously the core idea is that like you write lock, and then once the write is finished, you can read all across all threads. And if there is no write lock, you don't need that first step.
Oh, because I think
That's the whole
I've
message
seen
part.
I've seen the struct sanitized message before, and I was pretty confused. Why is like what type of sanitation is actually happening? So thanks for answering that.
Yeah.
Yeah. So
Yeah. So I think I wanted to go like a deep like into that because I've been very so like me and the guys, which is like parallel too. So we've been trying to like join the efforts in like trying to decouple the RPC too from the validator. So it's like it's more of so it's increase the callbacks on the geyser and then like optimize the geyser so that it can take all the data points that can be found at the bank and then take the data directly from the geyser instead of using the bank. So it's kind of like high level, obviously, but still very much in like research phase. But like I wanted to just like really, really go into like the banking stage itself, four banking threads. I think two votes threads, right? It's a four banking threads, two vote thread. I think somebody was making an SIMD to make it one. But I think I want to go deeper into because like you guys changed like the scheduler. I think it was sometime last year. It was so it's the central scheduler. I need you to like kind of can you walk us through like what that change was and like what was the previous problem with like the greedy iterator scheduler and like what this new one does?
You want to go through the scheduler changes that are recently happened?
No, like the recent scheduler changes. Like the central
To be honest
scheduler.
with you,
Yeah.
I don't work on the scheduler, so I don't really know all the
Oh,
details and
okay.
the nuances of
Yeah.
those changes. There's
Yeah.
I think there was either a core dev call or something recently where Andrew went over some of what constitutes the greedy scheduler.
Yeah.
But for the most part, I don't know all the details about how those things work.
honestly, like
That's really
I
that's
have to
super
give you
cool.
applause for
So
that. Not a lot of people can
yeah,
legit say I don't know. Like that's a very
yeah.
impressive feat.
But
Well, if I
that's the
tried
thing.
to explain to you how the scheduler worked, you would very clearly see I didn't know what I was talking about. I mean, I can tell you conceptually what it does,
Yeah.
and I know how it works, and it ties
Yeah.
into the like parallelism we were just talking about, but I couldn't tell you exactly what has
Yeah.
changed
Okay.
recently.
Okay.
Yeah.
Instead
It's
of
not
okay,
my part
sorry.
of that.
Instead of making it like
Yeah.
go in depth, since okay, this is supposed to be for regular devs, can we like okay talk
Yeah.
about what the scheduler is, like educate people on what the
Okay.
scheduler is and how it fits
Yeah.
into the whole puzzle.
Sure, yeah.
Yeah.
So what it is like basically it's kind of aptly named. It schedules the execution of transactions, and what it's trying to do is like the core scheduler components that are part of Agave that like we ship at Onza that ship like have always shipped since like the inception of the labs validator. The goal is to create the best like thread management system where you can have as many transactions firing in parallel as possible. There's been upgrades over the last few months, maybe a year or so, that have sought to try to like improve on those things, right? So like for example, we had some pretty strict rules about what kinds of transactions, like how many writable transactions you could have in a single like entry. And so we've really increased the number of writable transactions. Another interesting thing that is being worked on now is like I don't know. I guess I'll go into that in a minute, but before I want to at least finish my thought on the scheduler. So what it kind of is designed to do is like put these transactions into a schedule that allows them to be like parallel processed, and it does that by keying on these like readable, writable type of things that we're talking about here. There's a marketplace that's opening up, not necessarily a marketplace, but an area of competition right now where people are trying to create schedulers as like additional components to the validator. And I don't exactly know how Firedancer is going to set theirs up. They've talked about tiles and stuff before. So there's some things that could be pluggable. But what some people do, notably Jito, is they have forks of Agave and then they modify their schedulers. So you can have like basically block scheduling and block production being like these decoupled components. And I think that's like an increasingly popular trend. It's not just on Solana too. It's on a lot of chains that people are trying to have like these decoupled scheduling components. And the idea there is like you get a purview into what transactions you're sort of like able to put into this block within the CU limit. And there's a number of things that you could do. Like you could have certain amounts of a block that you're about to create if you're a leader that you want to like use for certain transactions that do maybe some specific thing. Maybe you're collecting tips because you're like a Jito validator, whatever the case may be. But that's where like all that kind of magic happens. So when you hear people talk about like tipping and MEV and stuff like that, like the scheduling component, the ordering of the transactions in the block, that's where that's going down.
Yeah, and it's also pretty fascinating. I'm noticing a trend in Solana where it's like we're constantly trying to tear things apart, because just now you said we're tearing some parts of, was it the scheduler? I can't remember.
Yeah, the scheduler, the couple of the scheduler,
yeah, and it's the same with the code base, because it's really weird. Previously, you could just import everything from SDK, but now, especially with Molox, with Molox?
Yeah.
No. Okay, it's with Light SVM. With Light SVM, you have to import everything from like Solana Key Pair, Solana this. So like, what was the thought, or why do you think what's the reason for making everything so, should I say, composable or splitting things?
Yeah.
Is there like a...
Well, there's a couple of benefits. So for starters, like we went down the monolith approach for a long time, and these kinds of decisions were long before my time. But basically, this huge code base with the validator, with all of the DK that you use to write, not just the validator, but the tools, the RPC that you mentioned, pretty much all these things that are just like co-located in one code base. Then you have them released at the same like release cadence under the same like release
version,
and they're like pretty relatively incompatible if you try to like do any kind of development on one component, and like not a lot of them follow Semver, and so there's like the code management side of things, but then there's also the like validator health side of things. So like one thing I've always thought was interesting that I think other ecosystems, like validator teams and other ecosystems, have done a good job of is like having these like pluggable pieces. So like we carved out the SVM interface. That's kind of like that's been successful so far as like a start of this, and soon we'll try to do RPC and maybe some other components like the scheduler. Who knows? Basically, whatever people kind of want decoupled first. But the idea is like if you have this validator that is like created based on a bunch of like components that fit together through well-defined interfaces and can be interchangeably used, then you have a little bit more of a diverse network as far as like different software that bugs could be found in. So for example, if you guys write like an RPC and like Triton writes another RPC and Helios writes another RPC, and now we have 3 different RPCs that can like be, let's pretend we're still in like the validator and RPC are the same. Thing. You could plug them into Firedancer, you could plug them into Agave, you could plug them into Syndicate, you could plug them into something different. And the idea is that you have these different combinations of RPC and validator all across the system. And if you apply that concept to like many much smaller components, like even just like smaller things, like maybe somebody writes a better bank, whatever the case may be, like if one has a bug, the other one maybe doesn't. They're like,
yeah, exactly. Yeah.
and then you
That's
have like
insane.
this like proliferation of components that could save the network if there was a problem.
Yeah, there was the 0-day attack.
So
Yeah,
basically,
that's super cool. Yeah.
you guys are basically decentralizing the code base.
We're trying, but it takes a while
Yeah.
because like we're trying not to break anything, and
Yeah, that's your great. Yeah.
That's
it's
so
not so easy
exciting.
to do.
Yeah.
Yeah. I'm like it's super cool. Like I never really gave much thought to like the direction of like having like individual validators run their own custom like schedulers and banks. You know, I've never really thought about this. This is the first time I'm actually
Same.
thinking about it. You know, it's really cool and it's really aligned with like the decentralized ethos. And yes, exactly. If if multiple validators or operators like run their different solution, it's very, very difficult for all of us to replicate the same bug. You understand? So yeah, obviously that's like kind of like an advantage security like security in the direction of security. That's super cool. So like
Yeah, I
yeah,
mean,
I never really said
this is what consensus is for, right? So like
yeah,
there's nothing stopping any node operator from taking the software and modifying it. You know, like
yeah,
that's the challenges of blockchains. Is like you can download our binaries, or you could download our source code and build from source, and you can change that source. And a lot of people
yeah,
do. But the fact is, like, there's a well-defined rule set that if you don't follow it, you're going to fork
yeah,
off, and that's
yeah,
exactly the way it's designed. So there will be advances in the protocol in the future that try to mitigate some of that risk. There have been in the past a lot of advances in the protocol that just, well, like things that needed to be introduced to say, like, okay, you can't particularly do this thing. But so far, I think, I think the rule set of the Solana protocol is pretty good, and it will continue to improve. And there's a lot of people who are clever, and they can innovate within those bounds. And sometimes it's for their own gain. Sometimes it's to create like a more democratic, like marketplace type thing that is for multiple people's games, for something that
yeah,
overall like increases like the quality of life for people in the network. So
yeah,
there's a whole wide range of reasons why it's like good to have validator
yeah,
operate, like tinkering and innovating. But ultimately, that's what the consensus is for, so that you can't
yeah,
just like
yeah,
run some like, malicious node and like alter the chain.
yeah,
Okay. Now
yeah.
Definitely a cool concept.
That's
I have a greedy question, or should I say a selfish
yeah,
question? So Ilios recently announced that they are trying to like split the RPC from the validator. And it was pretty crazy because that's something that me and FX we like were looking to like do. So
yeah,
what I want to ask is I have two questions. My first question is okay, what do you think are going to be the challenges in splitting the RPC from the validator? And my second question is that the fact you said that, okay, the code base is becoming more composable, meaning there are going to be smaller parts and people are going to be able to build theirs. What do you think
yeah.
is like the least challenging part that people could like go experiment by themselves? Like, let's give something for devs to go do right now that they could play with.
Yeah.
Okay, those are good questions. I'll start with the first one, the RPC decoupling. So there's kind of a lot there to unpack. Like the thing was built, like I said, with like a bank component readily available. So
Yeah,
it's kind of got like I don't want to say God mode, but it's got like the ability to read anything it needs to. So
yeah,
when you try to take that away, you start to discover exactly like how tightly coupled things are. I think some of the main pieces, like first of all, you need a good, reliable read layer. So like if you're not on the node anymore, if you're on a different server, you need to be able to get account state information that's like reliably fast.
yeah, fast, yeah,
But if you're talking to a node, even if it's like in the same server rack as you, like if it updates account state, you need to know about it right away.
yeah,
Otherwise, someone's going to read something that's out of date. So you need like really snappy
yeah,
updates coming from now somewhere else. If it's on the same machine and you're connected to the same bank instance that the validator is
yeah,
running, you have real-time updates. And
yeah,
so having to replace that relationship is tricky. But to be honest with you, I think there's people that have already figured that one out. Like some of these
yeah,
RPC gurus, like the Triton and Helios of the world, like these guys probably have that figured out already. I don't
yeah,
know. Some of the trickier parts are like I think the one that we were trying to figure out a really good solution to was simulating a transaction. Because similar to what I was saying about like the read layer, you need to get some information about the chain that is like current so that you can simulate a transaction. And then you need something to simulate it through. So you need the VM and you need like some semblance of like a program runtime, or at least just the latest compiled program of some instruction. So to give you like a small overview, like if you want to simulate a transaction, you obviously have a list of instructions in there. Like you're declaring which programs you're going to be talking to. Those programs could CPI to other programs. So you need to have those programs around, and you need to have the latest versions of them around. And then you need to be able to simulate them through the VM. So you need like basically SVM, or you need like part of it,
Yeah.
which is why it's nice to have a decoupled SVM right, without the rest of the node. So you could have like an RPC simulating service that just like has a SVM environment and doesn't need the rest of the
Okay.
But the tricky thing is you need to get information about the cluster. Like you need the latest sysvar information. You need the latest, like you might need stake. You might need information that is like contextual to whatever this thing is about to run. And if it's not the same, it could be a little bit dangerous.
Okay, so I'm not really okay. So basically, you're saying that splitting the validator from the RPC is turning into on-chain, off-chain game, where the RPC you're simulating needs to be able to get accurate data from the validator.
That's right. Yeah, because right now it does like automatically. It's like it's right next to it, like it's on it. So everything it's reading is like what the validator is reading. But if you put these things on two different machines, now you have to have this communication that's obviously going to be slower.
Yeah.
That's pretty interesting. So someone who's trying to like do this has to like look into off-chain and on-chain solutions, probably things that oracles do and all that. Well, wait, okay, random question. Do you think there's any decentralized oracle out there that actually does what it's supposed to do?
I don't know, to be honest with you. I would have to look into something more. Sounds like you're a little critical.
I guess that's for us to research. Thank you.
Okay.
I don't really think Perlin boxes oracles. I don't know, I could be wrong. I don't know. It's like you had a very critical tone to the way you asked the question.
Yeah, the first time I heard about oracles was from I think do you guys know Whiteboard Crypto?
Oh yeah, totally.
Yeah. So there was a time he did like a roast on different protocols, and there was one he talked about one oracle. I'm not going to say the name of the oracle, but he basically said humans lie, so they made a machine that could lie too. And I was like, what? Like it was pretty crazy. I was like, bro, what do you mean by that? So I get that a lot of people are skeptic about Oracle, so that's pretty challenging. I guess there's also I think a substitute for oracles are typically like zero knowledge VMs or zero knowledge proof. So that would be a solution where I'm thinking it's going to be really slow to be able to do that. Right?
Yeah.
Okay.
I think most of the problems that come with like especially like decoupling the RPC from the validator like they're more distributed slash DevOps problems in the sense that like it's not really blockchain specific. It's more like you need to look at the how this problem has been solved between client and server relationships, off chain. It doesn't necessarily have to be like how it has been done in Ethereum, how it has been done in movements or whatever chain. It's just basically looking at probably like a Google, probably like a Google, probably like just looking at like data centers, how do they try and like solve these problems? Like I don't really have like a like general review of like what exactly could be the major challenges, but like yeah, we're just constantly researching that. Probably we'll figure it out if we hit like if we hit hitches, we're just gonna ask the other guys. They're smart. If they're not busy, they probably answer our question. If we don't, we just have to research it ourselves. But like I did want to ask a question that's been like tinkering in my head. because everybody really knows about like this goes back to like the CU. CU that's a compute unit. I just recently found out that like CUs, not recently though, like a few months ago, but it like blew my head. Yeah, Wu and I fairly knows bro. So like it blew my head like when I realized that CUs were not like compute units were a time-based thing, not like a resource-based thing. But like it ties into each other because time is also resource. But like it blew my head. So I wanted to ask the question: how does like proof of history tie into like ordering transactions and so on? And like just tell me I realize that the clocks are very, very important for distributed systems. How does the proof of history tie into the runtime? Like if you could just break that down for us.
Okay. Well, technically, it's like the relationship is a little bit reversed. So,
Okay.
like, proof of history is the way that like the network registers hashes, and it creates a hash chain. And
Yeah.
this hash chain is like you guys have probably heard already. Like, this is like the passage of time, and like things like that can sort of like be
Yeah.
programmed to that.
Yeah.
But ultimately, how it works for like processing programs and like consensus is there are entries in blocks that can contain transactions. And so proof of history, every like deterministically is registering a tick, which is like
Yeah.
a new hash. And sometimes those can contain entries of transactions, but they don't necessarily have to. It kind of depends on the timing because you want to be deterministically like proof
Yeah.
of history hash.
Yeah.
But sometimes you might have a batch of transactions. So while you're like registering ticks, you're like doing transaction work, and then when you're done, put it into one of them.
Yeah.
Right.
Oh, yeah.
And so like you have this consistent hash chain going on, and then suddenly, like in one of the new hashes, you put up you put the hash of
Yeah.
That's called an entry. And so
Okay.
in this transaction processing land over here, this is where all the runtime is happening. And like that's a little bit of an oversimplification, but the idea is that like there is a POH component that just does that. And then every so often it's given a hash of like an entry to put in there. And the rest of that work comes from the runtime. And it basically says like it keeps track of a lot of things about the cluster, right? But ultimately what it's doing is like taking transactions inward. I don't necessarily consider the scheduler part of the runtime, but maybe some people do. It's more of like part of the validator stack, maybe even like a networking component. I don't know, but ultimately it it feeds the runtime the information it needs. It gives it the instructions. Like, the runtime to me is you give it instructions, it does something, and so those instructions are transactions, and you give it the instructions within those transactions, and it loads programs and it does stuff. And so the runtime is a state transition function. It's the SVM state transition. And so that's all you're really doing is just like you're like applying a state transition function to the account state ledger, and you're storing information about what happened in the form of transactions and like results into the block. And so keep track of the account state so you know what the state is for the next set of instructions. But ultimately what you care about is like what changed, like what's the state diff, and then that's the information that you register. And then inside of that runtime aspect, there is a lot of work that's happening to just simply the act of like taking third-party software, putting it into a sandbox environment, letting it operate on a set of like well-defined instructions, which also can be pretty user-defined because like you can just put like a big blob in an instruction data, and then like letting that thing apply changes to account state, like letting that thing determine the state transition function within the bounds of the protocol, and then like taking that information and registering it into the hash. That's like all of what the runtime is doing, and there's so much involved in there, from transaction sanitization to like program caching and like compilation like ahead of time, and like a lot of stuff like that. So it's extremely complex. That's kind of the
So super cool. But yeah, I think this is like a segue into like the question, like segue into profiling. I think this is more of like Alexander question, but like they said, answer engineers have the best profiler on the streets. What do you guys have about
I think you guys need to get on Twitter and tell Alessandro to start sharing.
it?
He probably would
Yeah,
share some of us. I'd never asked him, to be fair, but it's
yeah,
extremely complex.
yeah.
But yeah,
Okay.
there's a lot of tools that we use. To be honest with you, I don't do any kind of profiling, so I don't know what they are. I know his thing looks pretty robust, and we get tons of PRs from like whoever uses it. So
Yeah.
I think that's been pretty cool. The thing that you guys mentioned ahead of this call was like profiling CUs. I think that would be fun to do. I think it would be great to have like a more fine-grained way to profile CUs. Like I would love this. I would love to be able to like look at my program and not have to like compile it and test it and run it just to know what the CU consumption is. And I would like to know what the CU consumption is for like smaller bits of my program too. Like it'd be great to have like a data structure and be like, I wonder what this like, operation
Yeah,
costs. And
like that's a project I've been like looking into, and the only
Yeah,
resource we have right
probably.
now is the way people do it typically is that the compute units, remaining compute units, syscall. So
Hmm.
they basically put it on top of like a code block, then they put a code block, then they put it after. So I thought about it that that's going to be too slow. So we need to like look into it more. But honestly, I'm a systems engineering noob, so I'm taking my time to like look into it and like
Yeah,
get it. But it'd be so fun. Just imagine like you have your code and by the side you just have the compute units. Like it would be so
yeah,
fun.
it's crazy. That would be crazy.
That'll, I mean, that'll work.
Really.
I
Mm.
forget exactly what the cost is, but I'm pretty sure it costs you compute units to view your remaining compute
Yeah,
units.
yeah, yeah, yeah. It
I
actually
don't know if you have to
does.
like tangle with the accounting there, but I'm assuming you do.
Yeah.
A better way would be like if you could just write a Rust test and it would like tell you what the CU usage was. And I don't know, we might not be far off from that. Like a colleague of mine is working on a tool that he's got that lets you run Rust unit tests in the VM. And like I
Mm.
tested it out the other day. I don't want to like, I'm not going to release any details about it. I want
Yeah,
to,
yeah.
but I think it's pretty cool. But you know, we were chatting a little bit about what we could do for CUs, and other friends of mine, like across the ecosystem, have suggested some really cool ideas. But I mean, so far, the biggest thing, like, it's not impossible to do because the way that these CUs work is like the runtime itself has declared that the rule is going to be like one instruction is one CU. And these instructions that I'm talking about are like the bytecode instructions, the opcodes.
Yeah.
So like if you can just compile a function into opcodes with the Solana compiler like
Yeah,
platform,
yeah.
then you have all the information you need. You don't even actually have to run the code.
Hmm.
You can just look at the instruction count and there's your CUs.
Yeah, serious, yeah.
But maybe somebody just has to do that.
Yeah,
Yeah.
yeah.
That's pretty interesting.
Okay, yeah, that's obviously that's the besides. Okay, I think the next question for me is re-entrancy and what exactly is re-entrancy and how if it's possible to have like a re-entrancy vector or vulnerability on a Solana program.
What exactly do you mean by reentrancy?
like
What?
like re-entrancy is basically when a program calls like an instruction calls let's say instruction A calls instruction B and then instruction B can call instruction A, basically locking accounts that instruction, it's kind of like I get pretty confused when it
Okay,
comes to it, but
okay.
it's just basically
It's
like
on. Okay,
yeah,
I gather like on Ethereum now. There's this
yeah,
attack called the re-entrancy attack. So basically, when you
mm,
make a transfer, it calls another function. So like attackers just like they put some code to call the first program again. So they trigger another transfer without the state updating. So
updating
basically, it's
exactly,
just
yeah,
like, okay, calling like a function calling itself. Like think about it like it's taking funds out of a program repeatedly before the point where it actually registers that, oh, this person doesn't have the funds there
yeah,
again.
yeah,
Do you get it?
yeah,
Oh, that sounds rough. Yeah.
Very rough.
So
yeah.
we do have a number of ways that we prevent that. it's not something that I perceive as a risk on Solana, because there's a couple of things. So first of all, when you CPI, there's actually a CPI limit. So like even if you're CPIing to yourself over and over again, like eventually you're going to get stopped.
Yeah.
That limit is increasing, but still, like arbitrarily, you're not going to be able to go very far. So besides that, though, when you do CPI, you get the latest account state. So like the account state right now is unfortunately copied, but soon will just be mapped. But the point is, like, there's a region of memory in the VM when you first enter the top level instruction. So if you're like instruction A, you get all of the account state in your input region of your memory. And then when you CPI, that memory gets, again, copied, unfortunately, but it's copied. And so if you change, you're going to have the changes. Like you can do this experiment yourself. Like you can create a program that like reads some account state, and then you can like update it on program A, CPI to program B, read it, do it again, and you'll see. And like the changes are aggregated until the very end of the top level instruction finally finishes, and then the runtime comes back with the information. So you'll always have the latest update whenever you CPI to something. So if you end up CPIing from A to B and then B back to A, like it won't be the same state that you started with.
Okay,
So for those two reasons, I think we're covered.
Okay, I have a question. I've noticed that Solidity programs or Ethereum programs, I don't want to make this like a Ethereum versus Solana thing, but basically they are more like smart contract level acts. I've noticed there are more smart contract level acts on Ethereum than on Solana. And the only part where I feel like, okay, you can get like attack vectors if you don't validate your accounts right. So I'm curious, like why do we have less like why are we less prone to program attacks on Solana? Like are there other factors that like put this out together? Is it because of the account's already defined? That's what like puts everything straight.
So kind of. Now I'm not going to say we're like less prone to any kind of attack. I don't think there's enough really evidence to say that like either one is more protected. Maybe, but I'm not the guy to say that because I'll be eating. But for the most part, I think we have a lot of protection on the program side because of the explicit account requirements. So like you have to provide these accounts that you want to operate on explicitly every time, and you have to tell the runtime if they're supposed to be writable, if they're supposed to be read-only, if they're supposed to be signers. And yes, you're right. If you're a program dev and you're like not doing account checks, like you're going to put your program at risk for sure. And there's a lot of onus on the program dev to do that. And so it's a lot of reasons. It's actually a little bit, I wouldn't say easier, but there's a whole nother type of attack that you could do by just spoofing programs. So like you can spoof Solana programs by providing instruction data or unexpected accounts. So you can kind of like spoof it in two ways, or you can combine the two, right? So like if I'm expecting some account and I'm applying checks 1 and 2 on this account state, but I should be also applying like 3, 4, right? Like a couple more checks to make sure. Like maybe I'm validating a few bytes of the account state, but not the whole thing. Or maybe I'm not checking the length. Or maybe I don't check the owner of the account, right? And you give me a spoof, then like you could blow my whole thing up. And another way that Solana is a little bit sketchy is if you have like, you can create a program and then you can create account state under that program that looks just like other account state. And then you can send it to places. So you can spoof like ownership, like missing ownership checks that way. So there's I wouldn't necessarily say that any one chain is like super bullet. I think they all have different types of attacks that are available. Their architectures uniquely create scenarios where you just, as a developer, you have to be really thorough.
That's very
Okay, I think
fascinating.
I wanted to ask, has there like been any like are there like you said rules? So I want like are there like historical incidents that have shaped like Solana's rules? You know, like generally, like so like what
There's
were they?
I mean, there's been a few over the years. Some small, some big. Like So sometimes there's been some things that were just like smaller overlooked rules that we added. Like we changed the way that like nonces could be used in the past. I don't remember exactly all of the details, but there's definitely some kind of postmortem about nonces from a few years back. So this kind of stuff happens, you know. But ultimately, like Tully has always said, like the chain is designed to halt before like any kind of like catastrophic scenario could unfold. So whenever it does happen, like if you're looking to like create a different rule set or like update the rule set as a result, I think that's like well within play. But hopefully we don't have to do that anymore.
Yeah.
Just update the rules without having problems like that. But yeah, I mean, things happen all the time. Or like sometimes people just report bugs that thankfully have not caused any problems, and that changes the rule set too. Or maybe we are moving in a different direction, so we change some of the sets about the protocol to support what the community wants to do. You know, there's a lot of ways that the rule set can change. It's actually always changing, and soon when we have a lot of these more like grandiose protocol changes, whenever they start to manifest, we'll probably also have more rule set changes. Like for example, having more than one leader or having asynchronous execution. Those kinds of things are going to definitely need to have some rule book updates for sure.
Yeah, I have we're actually running out of time. Like what, 10 minutes down. So I think at this point we have to be a bit more cautious about time. But yeah, since okay, I wanted to ask a question. How possible it is to replicate mainnet states? Let's say okay, live states with testing states. Like how far off is like program test from the actual network in terms of testing? Do you understand what I mean?
Yeah. So like program test doesn't really know about what the cluster actually looks like for account state, for like anything like that. So you get all the same code that the validator runs. You get the same bank, you get the same, like you get everything the same, but it's not like pre-hydrated. So that's the main difference. Like you're running the same entry point and the same like API, but you need all the information, like the contextual information. So for example, if you want to like mimic DevNet, you need to get accounts from DevNet that you're going to work with, and you need to put those into the program test instance, and they need to look like the accounts that you're expecting on DevNet. That's a little bit tricky to do. It's easier to do with the test validator because you can clone accounts directly from the cluster. Program test is a little bit harder to do because it's more like unit testing and like on the fly. So, but you can still do it. Like you could clone a bunch of accounts and then run your unit tests on a set of fixtures, and it would work. But with program test or with test validator, that's baked in. So like you can have a script that starts a test validator and just clones a ton of accounts by ID, and it'll just get them in real time. And so that's pretty, we're close to real time. That's pretty good. But with program tests, a little bit more of a manual setup.
Yeah.
Nice. Do you think that's a feature you would like be curious to add to Molox at some point? Like to able to like copy account state from like account data to Molox for testing? Like do you think that's a feature you'd be like curious to add on later on?
Yeah, absolutely. Actually, I just put up a PR for kind of like this like really simple account loader,
Yeah.
and it's just like a wrapper around like a trait that says like give me an account. I don't really care like where it's from. And the idea is like instead of like because the harness is designed for you to explicitly provide accounts every time you invoke it, this is just an option for people who are like sick of doing that, or they're providing the same accounts every time, or they have to like take the results and like pipe them back in. This one gives you a way to just use like I mean, you could use whatever data structure you want, but the easiest one is going to be just like a hash map of a pub key and account. So that being said, maybe there's a way to have like account loading occur with like cluster params, and Anchor does a good job of this too, where you can just say like, I want these accounts to come from the cluster, and like maybe you have some way to explicitly define where to get them, like what addresses. But yeah, I'm open to it. I think
Yeah.
tests we probably don't need to go add that just because like
Yeah.
harness
Yeah.
is a little bit, I don't want to say it's
Yeah.
on its way out, but I think there's better tooling available now. I think the light SVM
Yeah.
tools are better, and I think there's just better alternatives. So we should probably focus
Yeah.
on improving those.
Yeah. So
Okay. So yes, I think I wanted to ask like just like a passing question, like just rounding up. So I wanted to ask like what was the most creative or unexpected way you've seen someone has used like the program runtime, and then like has there been any trade-off to that you've seen from the runtime perspective between using Anchor and manually written Solana programs?
Um, from the runtime perspective, I think I think it's not a whole lot different. I think the thing about anchor programs that makes them a lot different under the hood is that they're usually a little bit larger because like devs think that they're pretty succinct, but they expand to like quite a bit of code, and like the anchor libraries can be a little bit large. And I think there's been improvements on that recently, but typically those are a little bit bigger elves. And so they might take a little bit longer to compile, but I don't know if it's really that much. Like I don't
Mm,
that big of a
yeah,
difference that you would have like a runtime
yeah,
impact. Seriously doubt that.
mm,
But I think they cost maybe a little bit more statistically to
yeah,
deploy,
yeah,
and they take up a little bit more account state, but that
yeah,
really doesn't matter a whole lot. And I
yeah,
think the checks that you get out of it are like worth it, especially
yeah,
if you are just kind of getting started.
yeah,
No, I don't necessarily think there's like any huge runtime implications from
yeah,
the two types of
yeah,
programs. They're pretty similar. Once you
yeah. So
have a
like,
program compiled and you've got
yeah,
the x86 code, it doesn't really matter.
yeah.
okay, since
Okay, so like yeah, sorry, like jumping back, like always, like the original first question because it was like two questions. So it's like, what's like the most creative or unexpected way you see someone use the runtime? You
Use the
know,
runtime.
yeah, like, like what's like, you know, somebody
Um,
use the runtime in a way that like you didn't expect that they were going to use it. Like, what's the most?
well, I think a lot of these like network extensions are doing exactly that, but not all of them use the whole runtime. Some of them do. Some of them just use like the lower level SVM stuff, and some of them
Okay.
have like rebuilt a lot of it too. Like if you look at the Atlas team, they've rebuilt a lot of the runtime layer, and like some of the primitives might still be there, but they've kind of re-implemented a lot of things and made that a lot of things like ideally more performant, or maybe they work differently. So that's pretty cool to see. I think there's a
Yeah.
number of work extension teams that have like just plug and played some of our stuff, which is cool. There's some people that have like integrated ZK, so like they've like gone through the runtime and made things work with the 32-bit architecture and work with RISC-V and work with like the RISC-0 ZK proving and stuff. So I think anyone who's kind of like ventured into that area is
Yeah.
definitely getting creative with the runtime and stuff. But there's a lot of the runtime that like some people like it's really only kind of specific to the Solana mainnet. Like you don't need to use
Yeah.
some.
Yes. Yeah.
So I haven't seen anybody use like the whole damn thing. But SBM stuff, bank even, yeah, for
Yeah.
sure.
Yeah.
so we have about three
Okay.
minutes left. Well, yeah, we've been asking you questions like back to back. Is there anything you want to talk about? Like something you've observed from working on the runtime that you which I'm asking you a question. No, you're supposed to like talk about
Mm.
anything you want.
It's okay. It's okay. It's okay.
Mm.
Yeah, so
No,
okay.
Yeah.
sorry.
From your view of working on the runtime, what's something you believe that would be advantage like would give an advantage to people who work on like just on the program side?
You mean like what would I
Like okay, from
what
your
would I
you
want to do?
yeah, like you work on the runtime. So what insights do you think are there any insights that you've gotten that would like improve how program devs write their programs?
Um, yeah, I think there's probably a number of ways that like so first of all, I think a lot of devs like don't necessarily care that much about like how CU meter works at first because they're
Yeah.
focused more on like building a product, and I think that's okay. But like, there's some information about like how some of the VM stuff works that would be useful to make their programs cheaper. Sometimes it's a lot easier to do than they think. So like explaining a little bit about how like the meter works and like where it comes from is useful. I think also there's probably there's a lot of things that people don't think about until a lot later in their program development roadmap about like the way their instructions are laid out. So what I mean is like we talked a little bit today about parallelism and like right locking. If you're like pretty careful about how you make your instruction set, like your actual instruction layouts for the input of your program and what you require the account roles to be, like if you're pretty slick about it and you like minimize your write locks and you can use a lot of reads, you can actually like get a lot of inclusion with your
Yeah.
transactions that include your program, like
Yeah.
they can get included a lot easier. And so if you think about some of the economics too around like why a scheduler, whether it's ours or like someone else's, would include a transaction, and if that transaction is like mainly just an instruction for your program, like you can design your program's requirements around that, and then you can like increase the chances that like transactions for your program will like land fast.
Yeah.
And like, sometimes that makes a lot of difference when you want to scale. You know, like if you have a really good layout and you are pretty cheap on CUs and everyone pays the same fee as the rest of the market,
Yeah.
you're gonna land.
Yeah. I
Wait,
don't know whether the code trips us at 2 o'clock. I don't think it does.
wait, it
But like,
didn't.
I think,
I'm surprised.
yeah,
I
yeah,
thought Google
yeah,
Meet was going to like kick us out.
yes, yes.
Wait,
So, but
I didn't
like, I think,
hear you.
yeah.
Like there's a
So I
limit
think,
on Google Meet calls, so we like it's usually 1 hour. We expected it to like kick us out,
yes,
but it didn't.
kick
So
us off. Yeah, yeah.
Oh, I got
So
time.
I
I got
think,
time. It's up to
yeah,
you guys.
yeah. So,
We can
yeah.
keep jamming.
So, yeah. So I think it's really about like the tools because I don't really write Solidity because like I didn't really learn blockchain. I read straight to Solana. So, but I know that there's a tool on Ethereum that allows you to see to lay out your instructions. I don't know, probably you should know something like that.
lay out your
Because you can
instructions
ask,
in what sense?
like you showed us one time
Oh,
in
oh,
group
oh,
chat.
yeah. So
Yeah,
it's called EMV dot codes. It gives you like the cost of each opcode. So that's something that I'm trying
yeah,
to like replicate on Solana. Now somebody is going to go
yeah,
implement my idea
yeah.
faster, but that's all right. So basically, it shows you the cost of each opcode, and it's like converts your code from like Solidity to U. So U is basically like the assembly version of Solidity, and it also converts it to like opcodes too, and it also has a debugger.
Yeah,
I'll send it to you. It's like
yeah,
pretty handy. So I think it's
yeah,
similar to what we talked about with the function block. So imagine you have a function and it just
Yeah.
converts it to all the opcodes or to assembly directly.
yeah,
So
yeah.
Oh,
Exactly,
nice.
because like yeah, because what I was going to say was that like if you have that tool like a tool like that, obviously it's just I think the reason why many engineers don't think of this stuff is because they don't have tools that could basically help them lay out. Like I for one would probably never have to think about this stuff unless I really want to like optimize my program. But if I had like a handy tool where during development I can just like pull it up, obviously I'm now like privy to utilize that tool to make my program more performant. So I just say like I'll say like the culture is basically built around the tools that we create for like the developers. So yeah, like if something like that could probably come up, I think developers could buy it. Just basically lay out the instruction sets. They see, how, because like I didn't really
is
Oh,
I think you went.
understand. I didn't really care for CUs until I started going deep into the runtime. Like exactly, like until I started going deep into the runtime. So I didn't really care for CUs. But like the moment, like the more and more I was diving down into like low level software programming, it's more like you now get to a feel for what like one add up code means, what sub up code means, and it becomes more and more expensive. But like so a high level Dash script client consumer, it doesn't really care. 200k CUs, it doesn't really care. So like if we can create more tools that I feel like we can create more tools that allow developers to basically you like understand what the consequences for their actions are. I think that's something that I think that's something that they could bite.
No, I
Yeah.
agree. I think I agree with that. I think if it was more like readily apparent and easier for them to read that kind of stuff, like if it was like a VS Code plugin or whatever the case may be, I think it would be pretty useful. And like I said
Yeah.
earlier, if you have that information, then you can like CUs are just a count. So like
Yeah.
get that information as well. But yeah, I mean, even like an educational aspect too. Like if you're writing a program and you've been developing for a little while, maybe not too long, you just started doing Solana stuff for a little bit, and you're like getting information about opcodes as you're writing a Rust program. You can learn a lot about how the VM works, and you can learn a lot about like basic programming, you know, by looking at that kind of stuff.
I sorry to cut you. I also have this idea that honestly I've not implemented it, so I shouldn't talk about it because someone is going to like going to implement it, but I'm going to like say it.
You're always so paranoid.
I'm going to say it as a reward to anyone who has listened this far. So there was a point on Ethereum where they had this thing called, okay, the way we call CU on Solana, on Ethereum it's called gas. And they had this concept called gas golfing. So it's basically where people just like, they try to shrink and shrink and shrink their code for like optimal performance. So I was thinking, imagine like a competition during like, let's say breakpoint or something where, you know, okay, devs are off their like computers and everyone is just having fun. And we just have like a sort of game or competition among all the devs. Dean is going to beat everyone.
Just optimizing a particular program. I'm down.
I think Dean, we're not going to let Dean participate. We can't let Dean participate. Because if you write
no, Dean is not allowed. What? No. I'm not going to be in the competition that Dean is on. Nah. I'm sorry. I'm sorry. There's no point to compete.
But what do you think about that? Like a CU competition across the ecosystem during like some event or something like that?
Yeah, I'm game. Totally. We should totally do it. There's some crazy people out there though that are gonna write everything in assembly and they're gonna smoke everybody.
Let's do it. Honestly, me personally, what I love is I love devs. I love when devs net out. Like there was a point in like Ethereum culture where devs were so freaking crazy. We had things like Golf Garfin. We had open source contributions to like Foundry. Like Foundry basically is like Anchor, like a framework for writing contracts, but on Ethereum. And it wasn't like just made by one person. It was made by the entire community. So honestly, my vision for Solana at this point is that let's make devs more active in the tools they use and building programs. It's not enough. Like it's very impressive when you have people like devs from like Exo Markets who they made their tool and they made their product and they still made a tool like Typhoon, and also other Chad who made the products like Or and still made a tool like Still. So I think it will really benefit Solana if devs really come together to like, okay, let's make things better for ourselves, because you can't baby devs. I don't see the point in babying devs. Like I don't see the point.
I really think that sometime around this year, there was like a step up in like the dev tooling side of Solana, because like we really saw a lot of like development as regards like refactor. I take a Gil kits on the TypeScript side. Pinocchio was last year, you know, but like Pinocchio really took took the fire on like this year. I saw something around Solana SDK. They were like modularizing it, so you don't have to download the entire Solana SDK crates. You just download what you need. You know, so like there are a lot of stuff, and like if we can just keep rewarding this kind of activities, I feel like the Solana devs are one of the most cracked people I know on there. In the community in the blockchain space. I just feel like all you just need to do is just give them a target. Stuff like this. Yeah.
What do you think it is that we're missing to enable to put things into perspective? Like some people feel like all these things need to come from like Foundation or Anza.
No.
But some of those things didn't, right? Like Pinocchio technically did, but I mean that was also like a collab with a lot of community members, and the SDK being broken up into other crates, that was not on our radar until Kevin from the community started doing it, and then he did most of that work. So you know, like we've clearly seen that not everything needs to come from these like orgs, but it seems like those are the tools that get the most traction. and that kind of puts a lot of people, like turns a lot of people off as to like why they would go build their other thing. But there's a grant program and foundation. There is like a really strong community about like anyone who builds cool shit. So like, what do you think to enable more of those things to get extremely popular, like Pinocchio?
Thank you. Honestly, I think it's a matter. This is pretty much what excites me. I think it's a matter of education, and that's why I think I sent you a list of the things I want to like make videos on. They are pretty weird things, but it's like beneficial to know a bit about this and that. It gives you a clearer picture of everything. So I believe dev education is actually like it's going to promote like people making their own things. If people understand how things work under the hood, they can build their own things. For example, still is just like a collection of helper functions to a point, and like still has only like let's say 3 or 4 macros. I'm not downplaying it. I love still, but like it just shows that the only reason like we had still is because of either Chad was able to like play around with native and he understood it enough. He's a shard, so it's easy for him to understand. So imagine if we had education on like parts that like a lot of people just don't get information on. We don't need to like make the 20th video on Anchor, building this program with Anchor. Like let's look at the obscure parts. I'm not sure if that's what is the right word to use, but let's look at the weird parts. And I believe that this will give people inspiration to build whatever they want to build. So I believe education is a big part. And also,
so like more intermediate level, like education. That's what you're kind of suggesting.
Yeah.
Like education that is a little bit more involved for like current devs.
Yeah, and also there's also it's not even just education on even Anchor itself. Not like imagine a video that's not explaining how to do something with Anchor, but how Anchor itself works. Like for me in particular, I do not know how Anchor works. If a majority of the community knows how Anchor works, we don't need to depend on a few devs to fix things in Anchor. The community could fix Anchor.
Yeah.
So that kind of thing.
Yeah, I think that's a great idea. Because I was going to mention as well, like I think these tools come out of people who have like a solid understanding of something and they identify a problem. So like Anchor obviously identified a major problem in that like native was like somewhat difficult. And that was really early. But like Steel is a good example of like, oh, well, maybe some people want like an alternative. Or like Pinocchio was an example of someone like, oh, there's a number of like CU like anti-patterns that are happening in like the base SDK. And unless you need the help or like need the assistance or want the assurance of like the Labs Anza SDK, you can use this thing if you want to take some of the training wheels off. So like you're right. I think identifying use cases requires a little bit of a thorough understanding of something. And I think that's a good point about the educational aspect, or at least like the content, because if I'm like a dev and I just like geek out on Solana stuff all the time and I'm like watching your video and I'm like, why the heck do we do that? You know? And not like that's the stupidest thing ever is what people say. It's the stupidest thing ever. And then next thing you know, it's like Sunday afternoon and they have a tool.
Exactly. That's how human society grows. Like I'm very sure that in a year, people are going to look at Solana devs are going to look at how they did things like in 2025 and be like, why were we doing that?
Why were we doing that? Exactly.
Yeah, and besides,
so many things.
Yeah,
there's so many things.
And besides,
but like, we have the benefit of like identifying those things because like someone like myself, like we're kind of in the code base all the time because like there's just like obviously people in the community like don't get paid to work on Agape, you know, so like they're not incentivized to be on it every day, and some people still are anyway because they're just chat. But the point is, you can't expect everybody in the community to know all the nuanced things that like Anza devs or FireDancer devs know. But we also like just like can't ship like every kind of
every single exactly.
Besides, you want all your tools to come from Anza anyway. Like you want them to be like, you don't want that. I would rather those come from like everyone else. So that's like maybe there's like some way to like get better communication of like, here's a problem that I know exists that I have done nothing about for some time because I just can't. And like maybe it interests some people in the community, maybe. but I don't want it to look like it's just like pawning work off either, you know? So it's a little bit of a tricky relationship, I think.
Yeah. I feel like Pearlie's angle, like if people understood more, they could take up the things that they want to do. You know, like obviously, like yeah, like I don't necessarily have to do this stuff because JC wants me to do it.
Right.
I could find something in like the entire SDK that I don't fuck with. And like I just go out and build it. I just build
And
my own. Yeah.
people have definitely
Yeah.
done that.
Yeah. So like if we can more and more like to just basically increase the amount of people that actually know what is going under the hood, more people are going to find stuff that they don't really like. And if they have the initiative to build like tools that give more people options, cool for us. It's a positive direction for the entire Solana dev
Yeah,
community.
and we also have to find a way to like promote like open source contributions. But I feel like this one is going to be based on who's in charge of the repo. For example, when I found the issue with Molox, I talked to you and you were like, "Okay, do it." Like that's
Yeah,
simple.
yeah,
We need
yeah,
maintainers of code base to be open to contributors, but this is very challenging because you have your job, you
yeah,
also have to do this and do that. But I feel like
yeah,
that would really like boost things if like it was like if maintainers were like open to contributors. And
yeah.
yeah, besides that, I had another thing to say, but now I have forgotten.
Well, I think, to be honest with you, I think a lot of maintainers, like in our neck of the woods, are actually open to quite a bit of contributions. I think there's kind of like two problems. I think on one hand, maintainers get a lot of noise, right? So like we
Yes.
locked down the Solana Tech Discord a while back because like
Mm.
obviously we can't just like answer dev help questions all the time about like writing
Yeah.
Solana problems. Like maybe we do need a team that does that somewhere. I don't necessarily know that we do.
Yeah.
It shouldn't be like the core validator devs, right? So like it
Yeah.
makes sense to lock that discussion down. But if you come into the Solana Tech Discord and you want to talk about something that you have that is an idea or that you're working on that you want to contribute to the validator, that discussion is always encouraged and always
Yeah.
you'll always get a response. I've never seen someone just not like get answered.
I think
Maybe
you
it takes
I think you don't even need to even go to Discord. Open a PR.
Yeah. I just
honestly, yeah.
Open a
That's the
Yeah.
but I can empathize with people about not wanting to put in a ton of work into something for it to not get accepted. I can understand that.
Mhm.
But I do agree. Like just throw up a PR and like
Yeah,
see
just
what happens.
yeah.
But the
Yeah.
other thing too, besides just the noise, I think there's a lot of like sometimes people just like don't follow through with things. Like they have like an idea and they're like, hey, we should do this and that. And you know, maybe the maintainers are like, okay, that would work. But or like sure, why not? Like if you want to do it. But like they're not gonna put it on their like priority list, then that thing
Yeah.
like may or may not ever happen. So I don't know. There's like ways you can figure out how to do this. Like we've talked to people all across the community, particularly like people at Foundation, about like could we have some kind of like grant scheme that like rewards open source contributors? Is there any kind of incentive structure we could introduce that would like work and scale that would like
Yeah.
give a way to get rewarded for like putting in that kind of work? Because I could, like I said, I totally understand not wanting to work for free.
Yeah.
But nothing like it's hard to figure out because if you lean too hard into
Yes.
the
Yeah.
bounty aspect, then you end up with like these spam.
Gamification.
Yeah,
Yeah.
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 Well, I think the solution is at the social level. I think the solution is at the social
Yes.
level.
I
It's at the
do
so.
see. I was
Wait,
about to say
yeah,
that.
what
Like,
do you
yeah.
mean?
I mean by the fact that okay, take for example, me and FX, we really like to go deeper into things. We're not answer
Yeah.
level yet, and we want to be answer level. So this pushes us to
Yeah.
like tinker into a lot of things, and a lot of people like tinkering. For example, now on
Yeah.
Ethereum, contributing to code bases like Foundry, Red, Ilios, like they give you an advantage in the job interview. Like if you make significant contributions to these code bases in an interview, even if you've not worked in a company before, it gives you a higher chance. So on the
Yeah.
social level, if you like, let's say should I say, we encourage people like who solve hard problems or make like great PRs. Like let's say people like Naga Prasad. Like Naga Prasad is
Yeah.
always making great PRs. I'm not sure if you know
Yeah.
him.
Yeah.
Yeah, so
Yeah.
other people like this who make great PRs, if we encourage them, like if we encourage them more and make it like part of our culture, I think that's enough. Because the funny thing with programmers is that we're weird. If
Yeah.
a problem is stuck in your head long enough, nobody needs to pay you to fix it.
Fix it. Yeah. That's true.
Like we
Yeah.
fix problems. We like
Yeah.
it's if a problem is like if it's pissing you, you just solve it. So I
Yeah.
believe like if we encourage that enough on the social level, it's enough. Like for example,
Yeah.
now me and FX, we're not getting paid to do that. So my YouTube or whatever,
Yeah.
but devs
Yeah.
just like solving problem, and if we like capitalize on
Yeah.
that, I think we could like accomplish that.
Yeah.
I
Yeah.
think
I
you're
think
right.
we could, but
I think
yeah.
there's some things in there that like maybe it's left up to just social mechanics. I don't think we need to like completely abandon the idea of like financial incentives too, though.
Yeah.
I'm not saying we
Exactly.
need
Yeah.
to do everybody for everything, or like I don't even know
Yeah.
who would have to like issue the payments anyway. But I think
Yeah.
like being motivated by wanting to solve problems, but also like having to like be able to pay
Yeah.
for your rent is like a completely acceptable way of business. And I
Yeah,
think
Yeah.
like in
yeah.
crypto, particularly like everybody's pretty pro capitalist and like wants to like make money on their own and stuff. So
Yeah.
I don't think that's
Yeah.
like a problem. And if there was a good way to do it, I think like there's a number of open source contributors I can think of that like it would just be great if they could just keep doing what they do and never have to worry about anything. And the way you do
Yeah.
that is have a setup where
Mhm.
they're going to be making money off of what they do. And that's how you keep people around. Now, you mentioned
Yeah.
like getting job interviews, though. That does happen. Like, I've seen countless devs that put up good PRs, solve legitimate problems, and have been hired in the community. It happens a lot, actually, which is why I
Yeah.
always tell people like just do it. Like so maybe you do put up some PRs and you don't get paid. You know, like open source contributors
Yeah.
not by definition paid work. It's not what happens. We can maybe change that a little bit if we wanted to on crypto, but payment. But what you do expect is
Yeah.
recognition, and eventually you can
Recognition. Yeah.
as a portfolio of work. And many people
Yeah.
have done that, and they've been successful. So that's definitely alive and well. Maybe we need to just like
Yeah,
have more
we
share
need
their
we
story.
need yeah, true. Maybe we should have like an interview with Naga Prasad, like open source people like really
Yeah.
puts things
Open
out.
source. Yeah.
Yeah, and also I'm
Probably
curious.
Cave.
Some
Probably Cave. Cave. Cave is actually a good community open source contributor. I know Cave does a lot of PRs.
You're talking about Caveman?
Yeah, Caveman. Yeah.
Caveman is a
Caveman.
OG. Come on, I'm not talking about
Yeah.
OGs. I'm talking like people who are running and are still pushing.
Okay. I get it. Yeah.
There's a lot of them. There's a lot of them.
Yeah.
Caveman's been around for a long time too, but there's a lot of them. I can think of many people, including people whose stuff that like I've worked on with them, or like stuff that they've contributed to, like programs that I was involved in working on at the time, and then they landed jobs. You know,
Yeah.
it happens for sure.
Maybe
And that's cool. That's cool.
maybe that's a different series to make.
Yeah. Yeah, I think probably, and this is not even really authoritative. This is just like a suggestion, but it's like maybe you could probably look because Ethereum is like a 10-year. Is it like a 10-year? It's 10 years old, and then Solana is like 4 or 5. So probably you should just probably look into the Ethereum community. How do they